In the last tutorial, we learned how to use the Pluto Notebook to document our work by learning how to use Markdown and LaTeX inside of Pluto. Although our document looked polished and professional, at the end of the day, it was just a static document that we could have made using some other application.
Oh!
How can we take advantage of all of the tools available in Pluto to convert our dull, static document into an exciting, interactive tool? Well, let's find out. Welcome to Docco.jl, where I explore the vast Julia wilderness and turn my discoveries into wholesome Julia tutorials. We have a lot to cover today, so let's jump right into it. Let's start by firing up the Julia REPL and launching Pluto. Next, let's create a new notebook and title it Pluto UI Cheat Sheet. This is optional, but I'm going to customize this user interface like I did in the first tutorial. Let's save this file by using the Save Notebook bar at the top. By saving our file this way, as opposed to using the Export option, Pluto will know to autosave this file to disk every time we make a change to this notebook. Next, let's add a few packages. The Pluto UI package contains a lot of widgets that we will use throughout this tutorial. You've seen the plots package before, as well as the Plotly backend. The argument inside of the Plotly call is setting the default plot size at 360 pixels by 360 pixels. Now that everything's loaded, let's get a quick introduction to the Pluto UI package. Here are a couple of examples of general tools available from Pluto UI. Pluto will automatically create a table of contents for you by using your headers. By default, it will only go 3 levels deep. You should see an aside element pop up on the right-hand side of your screen. Clicking on it will reveal a table of contents based on your headers. You can toggle this view on or off by clicking on this icon. There's also a tool called with_terminal if you want to display your output inside of a terminal window. For example, when we did the Hello World example, the output showed below the cell using this format. Alternatively, you can display the Hello World output inside of a mini terminal window by using with_terminal along with a do end block. You should now see Hello World in a separate terminal window above the cell. So these examples may be mildly interesting.
Boring!
But what about all of that interactive stuff that I talked about? Okay, you've waited long enough. Let's get to it. So here's the good stuff. As you've already seen, variables work very differently in Pluto compared to the Julia REPL. Because Pluto is a reactive environment, you cannot simply reassign a value to a variable in a different cell.
No! No! No!
Nor can you increment the value of a variable like a counter. So, what can we do? Fortunately, Pluto UI provides a lot of tools that you can use to change the values of a variable interactively. In order to demonstrate how to use the Pluto UI widgets, I'm going to use the example of a virtual thermostat that shows temperature settings in both Fahrenheit and in Celsius. I've used this example in previous tutorials and it's become my go-to example for testing out interactive widgets. In this example, the user should be able to change the temperature setting on this thermostat interactively. Even though the user changes the temperature settings only in Fahrenheit, the thermostat should also be able to display the temperature setting in both Fahrenheit and in Celsius. Let's see how to do this in Pluto. The first widget is the single slider. You should see a slider widget appear above the cell. As you move the slider from left to right, the value of the temperature setting changes. Now, let's go through the syntax. The @bind macro is from the Pluto UI package, and it binds the variable slider f to the Pluto UI widget called slider. The first slider argument is the range of the values for the slider. The second argument is for the initial setting. And the third argument is a boolean for whether or not you want to display the value of the variable slider f to the right of the widget. As you move the slider, you're actually changing the value of the variable slider f. So this is one of the main ways to change the value of a variable in the Pluto Notebook. Now, this is just the value in Fahrenheit, so we need to calculate the value in Celsius. I wouldn't expect you to know this conversion equation, but it's easy enough to find online. Now when you move the slider, the values change for both Fahrenheit and Celsius. Pretty cool, right? This is only possible because Pluto is a reactive notebook. Now let's take these values and place them into some markdown text. You can interpolate the values of variables inside of Markdown by using the $sign. The Unicode for the degree symbol is just the tab completion of \degree. Now when you move the slider, all of the values change, even the values inside of the Markdown text. Amazing, right? Hopefully, you're beginning to see the potential for using such a tool. There are several more widgets to cover, but many of them work in a similar manner, so I'm going to go through the rest of these a little quicker. Next, let's take a look at how to display multiple sliders. In this example, imagine you're in a car with two thermostats, one for the driver's side and one for the passenger side. In order to do this, we need to enter multiple lines of code. You can enter multiple lines of code inside of a Pluto cell by using a begin end block. In this case, we're assigning the widgets to the variables driver and passenger, which we can then interpolate into Markdown text. This allows us to add some Markdown text to the left of the widgets. We still need to convert the temperatures from Fahrenheit into Celsius for both the driver and the passenger. In this case, I'm using Ctrl-M, which is the keyboard shortcut for Markdown. We can use Markdown to display the temperature in both Fahrenheit and in Celsius for both the driver and for the passenger. Now when you move the driver slider, you can see all of the values change for the driver side. And when you move the passenger slider, you can see all of the values change for the passenger side. Pretty wild, right? There are so many potential uses for this, so I hope you're getting inspired to try using these widgets in your own projects. The next widget is called a Scrubbable. The Scrubbable is like a slider, but it's more compact, so it's easier to include in Markdown text. It also displays the value of the variable inside of the widget, so there's no need for a Boolean to turn the value display on or off. Just click and drag on the value, either left or right, and the value will change. Let's convert this value into Celsius, and then use Markdown to display both temperature scales. So this is a nice alternative to the slider, right? The next widget is called a NumberField. The syntax for the NumberField is basically the same as the syntax for the Scrubbable. But with the NumberField, you can increment the variable precisely 1 unit at a time. This is useful since both the slider and the Scrubbable can be a little difficult to use if you need to be precise. The NumberField widget allows for precision, but as a result, it takes longer to move across the entire range of numbers. Let's go through our standard conversion and Markdown, and then take a look at the NumberField in action. Depending on your project, you may prefer to use this number field as opposed to using a slider. The next widget is called a checkbox. The checkbox assigns a Boolean to the variable checkC, stating whether or not the box has been checked. When you check the box, the value changes from false to true. This is useful for control flow purposes. So in this example, the temperature is displayed only in Fahrenheit by default. But when you check the box, the temperature is displayed only in Celsius. This can be pretty useful, right? The next widget is called a text field. As the name suggests, this widget reads the user input as a string. Even though the text input is read as a string, we can still use it in our thermostat example by converting the string into a number. Now, you're not limited to a range of numbers. You can enter in any number, and it will perform the calculations for you. Notice that Pluto is reading the inputs in real time, so there's no need for you to hit enter. Just be aware that this widget is meant to be used with strings, so you'll need to provide some error handling if you intend to share your notebook with other users. The next widget is called Select. With the Select widget, you provide an array containing a list of the possible values for a variable, and then the user can use the drop-down menu to select one of the choices. Like the checkbox, the Select widget is useful for control flow purposes. So that's pretty useful. This next widget is called MultiSelect. It's similar to the Select widget, but as the name suggests, with MultiSelect, you can select multiple values, so the output is an array. Notice that the variable multiscales is just a blank array. Now, try making some selections. Use Control-click or Command-click to select multiple items. When you select multiple items, the array grows accordingly. Using Control Flow, this allows you to display temperatures in both Fahrenheit and Celsius, or just Fahrenheit or Celsius, or to display nothing at all. So that's useful. This next widget is called a MultiCheckBox. It's basically the same as the MultiSelect widget, but it allows you to use checkboxes instead. As with MultiSelect, the initial value for the variable box scales is an empty array, but the array changes according to the boxes checked. This markdown is exactly the same as the previous example. All you need to do is change the variable name from multiscale to box scales. Now, there's no need to use the Control key or Command key, so using checkboxes is a little more intuitive for users to interact with. This last widget is the button. This button is a little unusual. The string that you enter for the button is assigned to the variable named random. When you click the button, nothing seems to happen. Now, you may be thinking, what's the point of that? In this case, it's not the value of the variable that's important. What's important is that Pluto will execute any cell that contains this variable named random whenever the user clicks on the button. This allows you to trigger an event that will change the value of a different variable. So in this example, clicking the button will generate an array with 10 random numbers that's assigned to the variable named data. Every time you click on the button, the values in the array will change. Let's plot this data to see what happens when we click on the button. As you can see, there's nothing unusual about this plot. Now, try clicking on the button. Amazing, right? This is one of the powers of using a reactive notebook. You can combine widgets with plots to create an interactive environment. Let's take a look at one final example that will apply what we learned in order to create an interactive plot. In this example, we'll create a plot of a straight line that we can manipulate using widgets. let's set up a couple of sliders so we can adjust the slope and the y-intercept of the line. For these sliders, I'm using an increment of 0.1 to make the plot a little more precise. Now that we have our sliders, let's set up the equation for a line as a function. And then, all we need to do is plot it. I know it doesn't look like much, but try moving the sliders. Pretty cool, right? We'll be using these interactive plots a lot throughout the rest of this tutorial series, so now you know how to create your own. Before we go, let's take a look at the table of contents that's been quietly hiding on the side. As you can see, Pluto has been busy updating the table of contents every time we added a new header. These are also clickable, so you can navigate to any section of the notebook by using this table of contents. This file should be saved automatically, so we don't need to save it. But let's click on the title in the table of contents, and then scroll up to the very top, and then export this notebook as an HTML file, since this file will make for a very handy reference file. I hope today's episode has inspired you to try out these tools for your own projects. We covered a lot of material today, but there are many widgets that I did not cover. Fortunately, there are resources available online pertaining to Pluto UI. I've provided links to them in the description below. In order to show your appreciation to the developers and contributors for this amazing reactive notebook programming environment, be sure to head over to the GitHub page of Pluto.jl and leave them a star. Sadly, this concludes our exploration of the Pluto Notebook. But this is by no means the end of our adventure. Armed with these new tools, we are now ready to venture into the exciting world of differential equations. If you made it this far, congratulations! If you enjoyed this video, and you feel like you learned something new, then please consider smashing that like button, leaving a comment, sharing this video, and subscribing to this channel. If you'd like to support the educational work that I'm doing, please consider making a purchase at the Doggo.jl online store. You can browse through a wide selection of Doggo.jl merch by clicking on the Store tab. For one-time donations, please consider using the Super Thanks button. For ongoing support, please consider joining and becoming a channel member. Channel members get early access to all of my new videos. Early access videos do not contain YouTube ads. New tutorials are posted on Sundays/Mondays. Thanks for watching, and good luck on your Julia journey.